Hey guys, welcome back to the channel. I know it's been a few weeks since we uploaded a video. We've been plenty busy, but today we're doing a 200 amp service upgrade here in Colonia, New Jersey. You can see the service behind me. This is an old 100 amp service. On the inside, I don't have my light set up. I literally just pulled up. We have this Federal Pacific panel, and it's got 1, 2, 3, 4, 5, 6, 7, 8 circuits, no main breaker. I always like when I can come in and replace an old Federal Pacific electric panel. They're definitely a fire hazard. There's been a lot of manipulation, a lot of things said about them, but the truth is sometimes those circuit breakers just don't trip when you need them, and so that's why they're considered a fire hazard. There's also many other reasons why Federal Pacifics are dangerous. One of them being is the bend radius of the conductors inside the enclosure. And when we go inside and start taking the panel out, you'll see how small the enclosure is. I believe it only held 8 different circuit breakers, and some of them were already double tapped. So this house, I believe, was built in the late 50s, maybe early 1960s, and it definitely needed a service upgrade here to meet the modern day demands of electricity and electrical use. Federal Pacific is a company that went out of business in the late 1980s after a New Jersey family had a home fire, and they filed a class action suit against Federal Pacific Electric. And since then, they stopped making these panel enclosures, although you still can buy Federal Pacific Electric circuit breakers, but I highly advise that you don't do that. In fact, one of the policies at my company is we do not add any new circuits to any existing Federal Pacific electrical panels. That's just a personal company policy, and it's not law. Watch here as this circuit breaker just falls out from the vibrations. Now, that's not the kind of attachment you want to your bus bar, for sure. Each utility company is different, and as a licensed electrician here in New Jersey, I mostly deal with 2 different utility companies. One is JCP&L, that's owned by First Energy, and the other one is PSE&G, Public Service Electric and Gas. Each of them have requirements for their meter installations, and I have links to both of those companies in the description below, should you like to take a peek at some of the common requirements of both of those utility companies. So I like setting up everything here on the table. I got a couple of the Bohr speed horses here, or the regular soul horses, and then I lay out this little table, so I got a work surface to work on and make my knockouts. And I'm punching out the holes in this meter so I can get it ready to connect to the panel, which will go in before the meter. And then you'll see the rest of the video will be on the outside doing the service riser portion. Now here, the only circuit that we had with armored cable, this is actually a 20 amp circuit for the dryer line. I believe this is a 3-wire here, but it's only 20 amps. And then normally a 5,000 watt electric dryer is a little bit more than 20 amps, and you should have ran 10 3-gauge wire. It's working, and so we left it like that. But not shown in this video was some additional wiring that we did, where the window air conditioner in the living room was also tapped off this dryer circuit. And so part of the problem was when they ran the dryer and had the air conditioner going at the same time, they would overload the circuit, obviously. So while we were here the day or two before we did the service upgrade, we ran some conduit along the back of the house to supply a couple new circuits, one for the window air conditioner I just spoke of, and the other one was for a microwave that had a similar issue. All right, so now that I got all my wires prepped, I'm able to start them by putting them in the top of the enclosure here, and their connectors. Love the white button connectors. We use them here too. I'll come back after we get the panel in. But being that I got the armored cable, I got to get that cable in first because it has a special connector that we cannot connect on the inside, so we have to put that in ahead of time. Now would be a good time, if you haven't already, to like this video. Definitely helps with the algorithm. And of course, I thank all of my subscribers and anyone watching this video. I hope that you get something out of it. If you do, smash that like button. If you want to see more, you can hit the subscribe. And I hope everyone has a good Thanksgiving. We're a few days away, and I got a light week of work this week, and I'll be off on Friday and Saturday and Sunday. Sunday I get back into the regular swing of things as I'm going to the Jets game, and I'm just used to being disappointed. So hopefully that'll be a change of pace this coming Sunday. These are the two new circuits that I ran. We ran them up into a junction box above the panel here, into a 4-inch square box into the back of it, and then came out of that with some 3/4 inch conduit. I did not take video of that because it was just too much going on that day, but just know that that's what those two circuits are. And so once I get these cables inside the enclosure, I could push it up. This is what's known as a flush mount installation, where it's flush with the finished drywall. I come back with some number 10 1-inch sheet metal screws, attach it to the studs, and pretty soon here we'll be ready to start terminating conductors and installing circuit breakers. Now, because I have my main disconnect on the outside of the house, this is what's known as a 4-wire setup, or a main lug only. We call it subpanel. There's nothing in the National Electrical Code that mentions anything about a subpanel, just panel boards. But this is actually a main breaker load center. And the reason why I leave the main breaker in there is because if we want to install an interlock later on for portable generator wiring, is all set and ready to do that. This costs me, as the contractor, about $20 more to provide the whole main disconnect assembly enclosure here, rather than just getting a 40 circuit main lug only 200 amp panel. It's just easier and a better installation to keep the main disconnect, or the main breaker, inside this panel. Now, this is not the main disconnect. The main disconnect is outside. So this breaker inside this enclosure is only to turn off power to the panel. On the right there, you'll see all the green terminals. That's my equipment grounding conductor bar. So all of my equipment grounding conductors get attached to this bar, and this bar is bonded to the enclosure, so the whole enclosure now becomes bonded as well. The neutral conductors are current carrying conductors, so they go onto a different terminal bar. And of course, the main bonding jumper screw that comes with this panel has been terminated, because we do not want to bond our grounded neutral to our equipment grounded conductor in a main lug only panel. Here is the required surge protector. Now, this is a plug-on neutral panel, but they gave me a surge protection device with the pigtail neutral that connects right to the neutral bar. Then from there, we'll start labeling, or we'll start installing the circuit breakers. I like to do these one at a time and try to install them as neat as possible. Definitely not a contest, and definitely not the most important part of the job. The most important part of the job is that everything is terminated correctly and in the right place, and everything is safe from an electrical perspective. Here you can see I'm terminating each of the branch circuits. That double pole 20 that you see there is actually my dryer line. It's undersized for the dryer, like I mentioned earlier, but that's what is there, and it seems to be holding. And so the main idea of a branch circuit over current protective device is to protect the branch circuit conductors. So if you have 12 gauge wires and conductors, you're going to have a 20 amp circuit breaker, and that's a part of the National Electric Code, Article 240, TAC 4D 7. I know that's on the tip of my mind because I teach that to the apprentices, and that's part of the curriculum to understand where that code section is. So we've been over it recently, and so it's on the top of my mind. Terminating these conductors, just do it nice one at a time. Single poles, double poles. One of the things we definitely have to do now when we have a multi-wire branch circuit, and I had a few in here, they have to terminate on a common trip circuit breaker. So what that means is when you have a 3-wire circuit, you're going to have amperage on both of your live conductors, the red and the black, and also on your neutral. The neutral is going to carry the imbalance between the black and red in a multi-wire branch circuit situation. If you were to turn off just one of those circuits, you would still have current flowing through your neutral conductor. And so the code changed a few years ago to require that both of the branch circuits on a multi-wire branch circuit be disconnected or turned off at the same time, so you cannot get that neutral and possibly get shocked by it. So that's the purpose of the common trip double pole circuit breakers for all multi-wire branch circuit conductors. Now I'm drilling a pilot hole to the outside so I know where to make the bigger hole with my hole saw to put the nipple between the back of the meter main combination and the service panel here. This will give you an idea of where to make my hole on the outside. I always want to make the hole just a little bit bigger than the connector, but not too big. We don't want it to fall in, but we will try to make this as airtight as possible when we're done here. And a little bit of wiggle room makes it easy in case you need to nudge one of the other enclosures together. Just to do a quick little test fit, it looks like it's perfect. And so now I'm going to come back with some spray foam, some insulation before putting the enclosure back up. I'm just going to install a screw here just to keep it in place, and then I'll come back and I'll wedge the duct seal behind the finished washer. Now here you got to be careful, because on the other side of the panel, on the other side of this enclosure, is the electrical panel. So we want to make sure we don't come through the panel on the inside. Setting this up, and I don't know if you noticed, but lately I've been using a lot of PVC risers instead of the service entrance cable. It just seems like I understand it's a better installation. I'm still okay with service entrance cable, but it seems like it's a better installation, and I just seem to be doing this a lot lately with the PVC, talking my customers in. Of course, you have the choice. It's a little bit more money for the PVC, but definitely a better installation in my opinion. These circuit breakers are known as plug-on circuit breakers. Panel boards, industrial and some commercial work, you'll have a bolt-on circuit breaker. These here, and you see me using in most of my videos, are in these load centers, are plug-on circuit breakers, which means you just attach them with no mechanical means, just push them on, and away you go. Yes, I'm watching Breaking Bad here, and I have the headset on. Breaking Bad, watched that with my wife many years ago, and I'm going through the series again now. Fantastic television show. If you're a fan of Breaking Bad, let me know in the comments what your favorite episode was, or any kind of comment about it if you'd like. All having fun here, all good. This main disconnect is where all my grounding and bonding takes place. So what that means is my grounded neutral conductor from the service is here, and also the grounding electrical conductors from the water main and the supplementary ground rods all get attached inside this main enclosure here, where the main bonding jumper is installed, forming what's known as a solidly grounded system. So I have a spring clamp mount for, I actually have a few of them for the GoPros, and I actually have a few GoPros. I probably should start doing some multi-camera shoots, but I'm just trying to give you a bird's eye view of what I'm doing here and what I'm up against. So here I'm just folding over my service entrance conductors so that I can get the cap of the service head back on. And you need to make sure that the conduit's a couple inches away from the finished surface on the side of the house here in order to do that, because you won't be able to get the back side on. Then they clip on either side and it's on. Now I could secure the conduit riser back properly to the house, which is what I'm doing here. And then shortly we'll be tying in our service entrance conductors to the service drop. Now, when you're doing this, when you're making the connection to the service drop, you just want to make sure that you do not complete the path to ground. Okay, so you don't touch a hot conductor to something that's grounded, which is why electricians use fiberglass ladders, because they're non-conductive. So now that my service entrance conductors are ready to go, I'm going to finish doing all my wiring before I reconnect to the service. And I'm just terminating my grounding electrical conductors here. That's the number 2 aluminum that goes to the water main in the basement. And here I'm attaching, which I've never done this before, I've never used a piece of PVC to protect the wire going down the wall. And it doesn't need to technically be protected because it is number 6 American wire gauge. I get questions in the comments, how do I get away with number 6? Well, because my water main is my, what we'll call a primary electrode. All right, and that's sized based on the size of the conductors of my service entrance conductors. And if you were to look at table 250 Tech 66, you would see that 4/0 aluminum requires a number 2 aluminum grounding electrical conductor for the water main. And then if you scroll down to the same section, you'll see supplemental ground rods required. And that conductor, which I get questioned on, never has to be bigger than number 6 AUG. Now AUG stands for American wire gauge. We can never put aluminum in contact with the earth because it'll deteriorate. That's also in the code section, I think 250 Tech 64. Thank you, Ryan Jackson, for that. And number 6 copper is the largest conductor that you'll ever need for service when you're driving ground rods to supplement your other electrodes on the property. There's the water main in the picture-in-picture. Didn't get too much video of that, but I wanted to include it in this video so you can see what it looks like when it gets done. So after I get the ground rods connected, we'll soon be ready to connect the service upgrade. If you like this video, do me a favor, hit that like button. Thank you guys very much. Okay, so as often is the case here, there's a lot of grounding going on, and so I sometimes use a double lug to connect all my grounding electrical conductors and my equipment grounding conductor, my grounded neutral conductor. I just, have to tap into that neutral bus with threads, and I use a 1/4-20 bolt to attach a ground lug directly to the bus of the grounded neutral from the service. This is also where the equipment grounding conductor is derived from. This right here is my grounded neutral wire. This is from the service. This is also my main lug only panel here. And so this jumps out from one side of the neutral terminals to the other side of neutral terminals, making all my grounded neutral connections to return to the source through the main disconnect and eventually back through that bare wire from the service drop. It's also important to note that you want to do the meter main terminations on the outside because there's less working space than there is here in this main breaker panel, which is why I terminate these last. Reconnecting to the utility company is not something I really think a DIY guy should be doing. If you feel comfortable, go ahead, it's your house. But I'm not even sure if you're allowed to do it without the electrical license. You would have to ask your building inspector or the construction department in your town. Here in New Jersey, as long as I have a permit and an electrical license, I'm permitted to do overhead connections and reconnections. But just like water in a faucet, you want to make sure you don't turn that faucet on while you're connecting. So what I mean by that is the water's just waiting for you to go, just like these electrons are waiting to go. And if you give them a path to go, they'll go through you and you could be electrocuted. A fatality is almost certain at that point. So I would highly advise not doing that. So once I do connect it, before I put the meter in, I'm just going to take my my Fluke T6 testers here and just check on the line side to make sure there's 240 volts between the legs. And then of course I'll also do a continuity test on my load side to make sure I didn't make any errors. And then once I get the all clear, I'm able to put the meter back in and then turn the main breaker on and start turning on the rest of the circuits to the house. This concludes this video. I know it's been a long time since I put out the video, about a month. I'm sorry. It's been busy, and with school, it's really a lot of work to do the school, do the prep for the school, run the business, be a good husband, be a good dad to my 2 dogs, right? Or actually 3 dogs now, but that's a whole nother story. and then finally be able to do my YouTube page. So there's a lot on my plate right now. So thank you for watching this video, and if you haven't already subscribed, I think you should do that. Have a happy Thanksgiving. Thank you guys for everything. It's been a really good year for Classic Electric and the channel here, and I appreciate all of you, and I'll see you on the next one. Thanks for watching this video. Be sure to subscribe, and we'll see you on the next one.